Hello and welcome back to the lab. Today on the bench we have a nice bit of vintage cal gear, a Fluke 3330B programmable constant current and constant voltage calibrator. This particular unit won't do AC current, so we still need the Valhalla Scientific. However, this one will complements the 5200A, and it's about the same vintage. So with the 5200A being the AC side of the fence, this is the DC side of the fence. 1000 volts, 100 milliamps, so won't do amps, but it does do milliamps. And has constant current and constant voltage modes. Should be kind of cool to get up and running in the lab. Working on some cal gear. It is a bit of a mess. Does need to be cleaned up pretty good, which we will definitely do. And I have a sneaking suspicion, because I can kind of see it, the needle on the meter's moved up to about here. So I think we have a strategically applied label, and this meter's probably going to need a bit of work. So we do have to fix some front panels. Now I have a second one of these that came with this unit. The front panel has been actually caved in and smashed. So we do have a parts unit that we can use to fix this unit, so absolutely we should be able to get a whole bunch of stuff going, and get this all patched up and fixed up. We also do need to fix this switch and absolutely clean all the controls, clean everything up. Then we'll even run a calibration on this thing and get it ready for service. So to start, I'm going to break out the alcohol. We're going to get this cleaned up. There are places where the covers are caved in on this thing too. Here's one of the covers that didn't stay on. We can see in the back where it's completely just... So we got some mechanics. Hopefully it works. We do have some challenges with this one though. These shipped with several different style of power cables. Now I have one power cable that will fit this socket, but the parts unit doesn't even have this socket on the back end. It's got a round cable with a bunch of pins on it. And it has a very, very proprietary power cord. So we're going to try to fix this one first. If I have to, we'll pop this out, put an NEC socket in there. Hopefully not. Hopefully we'll get it up and going. But, yeah, seriously needs cleaning. So let's get into it and we'll get it cleaned up. Okay, to pop out a bit of this. There we go. Kind of what I expected out of calibration gear. Lots of shielding, lots of thermal management, and still even has lots of dirt. We do have a safety interlock right here to make sure the covers are on. Not quite sure why you'd have a safety interlock on the top cover since you have to open it up to do the alignment, but yeah, we'll have to see. I gotta keep going because I do need to unbury these switches down at the bottom to actually get in here and get this patched up and put back together. So, let's see. Ooh, there we go. Okay, that's better. We're starting to get somewhere. Have to take some more of this apart. Okay, it looks like these two screws on each side is going to be the release to pop out the whole frame. So, slowly and gently. Don't want to yank any cords. Okay, we are tight, but it is coming out. Okay, here's the meter on this particular unit, and this is not going to be salvageable. I'm going to have to replace this meter. This movement is completely disintegrated. The armature's not even supported in here anymore. The spring is definitely off and bent up. Not 100% sure how this happened, but this meter is very toast and is going to need to be replaced. So it's a good thing I have another one. So we'll be able to swap this out with a good meter, and that shouldn't be too terrible. Moving up on the chassis, these LEDs came out with the front panel and they disconnected. However, all of this, the LEDs actually unplug. So what makes this really difficult is I don't have a lot of room under here for the binding posts. So they're off to the side, but it's all tangled up right now. But it does give me the clearance I need to service these switches and clean this up, because this is really, really tight. This is really, really tight to work on, and I don't want to get contact cleaner too many places everywhere. These are not potentiometers, they're rotary switches, so we'll be servicing them up as well. We have a nice array under here, which I'll bring the camera around, of reed relays. So I believe, at least from what I can see so far, no, this is just control. There's no resistor ladder up here. This bundle right here goes back into the analog core, which is here, to get everything squared away. We'll take the cover off this here in a little bit. So while I'm in here, I'm going to get the front of this glass cleaned up. Here's all the LEDs that are poking up that we ended up leaving. I believe these might be tellurium copper binding posts, but we'll see how see what's going on there. Next thing up is we got to get this half of this switch disassembled and get this taken apart, because if that's not the case, we have to replace this whole board. That's going to be a mess. Hopefully we can just fix this switch. Well, this was a pleasant surprise. The switch pack is actually removable. It uses a early socket with a screw in the center, and it does come out. Took some persuasion to get it out without anything cracking or breaking or getting destroyed, but we did get it popped out, and everything does look like it's good to go. So we can service the busted switch, get another end for this one, and then we can actually clean all of these switches and lubricate them so they are functioning as expected, because this is going to be one of the sore spots of the unit. So with this coming out, can be much more aggressive with the cleaning than we would if it was still stuck in there and I had to worry about the other switches. All right, after quite some time, the switch pack, I should say, is up and kicking again. Actually, I should probably clean up a little bit more. There's some junk on the power switch that we want to get off. Much, much less gritty. These switches are now moving the way they should. Everything's popping back and forth, in and out, like it's supposed to. And hopefully we have some electrical connection that we didn't have before. This switch pack is ready to put back into the unit. So we'll hit that first. Since we have the whole front panel apart, we'll toss the meter in. Now, one of the questions that I have is I definitely have two different era units that I'm working with, because the one we're rebuilding, this one, is the more modern one. It's got LEDs in it instead of incandescents. And we also have a knob change, which is kind of interesting. This is the knobs that come on the more modern unit, and this is the knobs that come on the more vintage unit that has the incandescent bulbs on the front panel. I'm more likely to put these knobs back because there's much more to grab onto, more meat on the control, and they did not feel as cramped when I was working on them. So kind of like these knobs actually going back on the LED unit, and I think that's what we're going to end up doing. But they need a clean for sure. And that front panel needs a clean. It's pretty bad. So next stop, I'm going to clean my hands because I have a freshly cleaned batch of switches. Don't want to just dirty them all up again. We'll pop the switches back in, and then we'll take a look at this meter situation, get that squared away. Might be ready for a power up and see if it's got some life and if we have to do anything to make it work. Okay, as we have run into meter problems before, quick inertial test, and the meter's moving nice and freely, actually quite smoothly. And I'll just pop this on a meter on resistance, not very long because I don't want to burn out the coil if it does work. I'm just looking for real quick. Yep, there we go. Okay, movement, and we are good to go. I did not want it to pop all the way over there. That can be hard on the movements, but this meter's in good shape, and it is ready to rock and roll, so we can put this in the calibrator. Okay, taking a look at this meter movement, we have a piece of wire that is up here that the camera's actually picking up okay. So we got this piece of wire right here that's supposed to go down through this hole, and I believe that's supposed to connect to the back of the meter and what floats the meter in the movement inside the meter. This spring is supposed to be folded all the way down, almost up into the this white ring. So I'm pretty sure this is the pivot point, or this is the pivot point, this wire that the needle rides on. So what happens is this popped off the back, this spring threw it up, and the needle dropped and got sucked into the magnet and is currently resting on the magnet, which is why the needle is so hard to move and is very dragging. So this movement, unfortunately, I'm pretty sure this one's toast. There's not going to be much way I can fix that. So short of replacing this meter, we were kind of stuck. Okay, upon closer inspection, we did have to swap out this switch pack because the boards are not identical, especially in the center area. There are some trace variances on the different boards. So we have to fix the one we got. The other problem is on the other one, which now is moving nice because I took it through the cleaning process, the power button doesn't stay latched. This spring is bent up a little too far and has lost its return. So this copper spring pushes on the detent, which causes the button to latch, and it's not doing that anymore. So this switch pack isn't going to work. This may have taken damage when the front end got hit on the other unit. I'm not 100% sure. So what I had to do was I had to unsolder all of these connections, burning through the conformal coating and cleaning out the desoldering tool quite regularly. So now I have to run the cleaning step on this switch pack because this one actually opens and closes like it's supposed to. And but these switches are gritty and they are terrible. So we have the center switch pack replaced already with the middle button now has the middle position now has a button. I do need to clean all the rest of these buttons and give this thing a general once over, more than once over actually, to get this flowing correctly, and then we'll throw it all back together and see if we get some operation. Okay, as we had to take off some structural components, I want to get this bottom cover back on before we fire up the unit for safety concerns. And there's a structural component that goes down the side right here that kind of holds all of this together. It bolts in here, bolts in here, bolts in for the analog core, and then for the front panel holding all of this stuff together. So we got to get all this stuff put back together before we can power it up, and hopefully we don't have to tear it down apart again. This lid, these holes are not exactly symmetrical, so if the center holes aren't lining up, flip the lid 180 degrees and everything will line up just fine. Okay, that worked way better than it should have. Alcohol to soften the label, little plastic razor scraper, and that label just peeled off. I do need to, the fog is more adhesive. I have to work at the adhesive to get it off the lens, but the label's gone and it didn't scratch the lens. So that worked way better than I expected it to, and that was fantastic. All right, here we go. Actually, before we do this, let's give the meter the best chance we can. And there we go. Mechanically align the meter. And let's give it some power. It is hooked up to the power monitor in the meter, so I'll be able to see what's going on. But we'll hit it and give it some power. And then we'll see what it says. Well, that's a good sign. Volts, voltage 1. We have 1 volt. It does go into constant current mode. Aha, 1 milliamp. All right, so that works. 1 volt, 10 volt trip, and crowbar is off. Let's see if we have output. Take it out of standby. I'm not unhappy with that. Yeah, not unhappy with that at all. Okay, that's perfect. I asked it for a volt. It gave me 9981 and some change. Totally not a problem due to the fact that A, my meter's not warm, B, the standard's not warm, 3, the covers aren't on, and 4, we haven't even taken it through an alignment. So this is an incredible start to this thing. It does have a brain. It is running. Let's ask it for 10 volts just for grins. 10 volts. Okay, so cannot complain about that. It's working. I'm going to let it do some burn-in testing on the bench. We'll run it for a half an hour or so and just let it get warmed up, see where it comes, see where it goes. And if it doesn't have any other problems, it gets a deep clean and then an alignment. All right, so after burn-in, we ended up taking a look at the current side of this unit just to kind of check it and make sure it works. Everything worked on voltage. It was fine. But the current side, it was stuck. It was faulting out. I current, essentially the LEDs would trip to I limit and it would go out of operation. Wouldn't output anything to the meter and was being kind of out to lunch. So starting the troubleshooting process, we ended up at easy solutions to complex devices, but in starting the troubleshooting process, taking a look at what was going on, we had a unit that had most of its brain. So on the voltage side, all the knobs would react, everything would change, crowbar would come on, these sliders would function, I could fault it out when I wanted it to. Voltage trip was working, the meter was working. The range switches were working, so everything was working. The meter was even showing current when the unit was off, or when it was out, which is normal, actually, for this unit. The high voltage supply does put out a little bit of power just to keep everything in balance and to keep everything functioning normally and not go off the rails. Speaking of off the rails, when setting it to current mode, the sense terminals have to be hooked up. If they're not, this unit can actually get damaged. So it has jumper links between output and sense, but if you pop those off to use 4-wire sense on whatever you're measuring, if the sense wires aren't hooked up or they're hooked up backwards, the unit can actually damage itself. So something to be careful of and keep in the back of your mind. So we have 80% of a brain. We know some sections are working, actually. Let's take the covers off. And we'll take all the covers off. Make sure it's unplugged so we don't put fingers on caps that are charged, because that's going to be foreshadowing, and caps are going to be a problem later. This is the ladder section. Essentially, this is what drives the front panel. The settings up here work over here. We have a pre-regulator board, a regulator board for the high voltage supply. Essentially, the way this works is has a control supply and a high voltage supply. Using the sense terminals, this opens up the pre-regulator, opens up the high voltage supply just enough to provide the output. So things aren't really, if you're using this at a low end, like 10 volts, things like that, things aren't seeing a lot of stresses up here, which is actually a really nice design, because the pre-regulator's tamping that down. So we don't have 1,000 volts on all these boards all the time. However, when we do crank this thing up, we do get 1,000 volts on all these boards. So as this unit can actually, I believe it's 1,100 volts is what this goes up to. So something to be careful of. And there is a safety interlock switch right here that does need to be on and will only activate if the cover's closed. I did have to put a bottom cover on it because it was not, there wasn't enough push on the switch just from the table to actually get it to engage. So we did have to install a bottom cover. So given that the voltage side was working, we have this unit, or the ladder's probably okay, not a problem there. Might have a problem in the meter, might have a problem in the current limiter. So we have the current limiter, chopper amplifier, auxiliary supply, reference supply, and then the differential amp. So I was thinking we may have a problem with these boards over here. Maybe the pass elements, probably not the pass elements because the voltage side was working and it's the same pass elements. But, so I was focusing my attention on this side of the unit. And I did notice, before plugging it in and turning it on, which was good, that some of the cards are different. So, especially for like the differential amplifier, this is the diff amp from the old one. The board layout is completely different from the diff amp that's in this unit. So their cards are not interchangeable depending on the series. And that is actually called out in the manual, that if the card numbers are not the same, do not interchange them because the pinouts are different. I found that out with the front panel too. So, as always, we start with the power supply. This is the pre-regulation supply. So we have two giant capacitors, a little bit smaller one. Then we have a couple of ancillary ones around the supply. These are essentially the bulk caps for the negative 25 and negative 5 volt supplies. So if those supplies are off, it's going to do funny things. It's not going to work quite right. So doing some in-circuit testing of a supply, we'll hit analyze, 0.7 and 1094. That's realistic, not necessarily awful. But, so that one's actually testing sort of okay. But this is the board that's not from this unit. This is the board that's from the other one. 278 on a 220. Okay, so we're starting to have problems. So 277 on a 220 volt, 220 microfarad, 65 volt cap. That's starting to get a little worrisome, and we're actually going to have to take a look at that. Checking all the other caps and rebuilding the supplies. Here's a couple of the highlights. I have rebuilt the supplies. I haven't tested anything yet, but I have rebuilt the supplies. So here's the one for the negative 5 volts on the one that was rebuilt. It's supposed to be 3800 at 15 volts. ESR is marginal. Capacitance is way out into the stratosphere, so we're not looking so hot. So, after rebuilding the supplies, which took dead caps, let's see what happens when we turn it on. The only thing we've done at this point is I've rebuilt these two boards. Everything else is original. And there's a bathtub cap that's in here that's actually going to need to get changed out because it's got PCBs in it. And that has a cancer problem. So that is going to have to go. The problem with that capacitor is I have to find out where to get a 4 microfarad 1200 volt DC capacitor. So that one's going to be a trick to source. Okay, so if I did my job right, we won't have any smoke. Alright, so no smoke, everything looks good. Power supplies are calm. We will ask it for, let's ask it for 10 volts. That's not a problem. Okay, hitting the operate button. That doesn't look too bad. So 998, it's actually a little, 9982. So we're getting voltage. Let's check current, see if we made any improvements. Or helps if you don't put it to, if you don't short out the supply when you move the meter leads. Output. And let's see. DC current. I'm asking for 1 milliamp. And we actually have 1 milliamp. Okay, cool. So my current range has come back It wasn't outputting anything before. So we definitely had a supply voltage problem, which means we're going to continue with the recap, because this unit's designed to stay on for quite some time, long warm-up times, high stability, things like that. So I don't want anything dodgy in there. So let's see if it'll go all the way up or if we have a problem. I'll do 10 milliamps. That is 60, so that looks pretty good. Keeping in mind we haven't calibrated this yet. 70, 80, 87. No, that should be 90, and it is faulted out. So we still have a bit of work to do because we are going into current limit. So we made improvements. We need to make more improvements. So this means continue with the recap, and then this will definitely need to be aligned because we kind of just destroyed all the drift, all the everything that this thing has had, so all the history, because we have to rebuild the internals. So it's all going to drift around and settle again. So, but it's stuff we got to do, because right now I can't leave this plugged in the lab in this state. It's just going to burn down, and that wouldn't be a good day. Okay, the current limiter board has been recapped. The only ones I'm not sure about are these guys, which were replaced by these. These are 370 mic, as long as I don't drop them. These are 370 microfarad capacitors at 75 volts. I had some 330s, so we'll have to see if that works. If not, I'll have to order some. Probably bump them to 4-ish hundred, but we were able to give them a voltage bump because I believe these are 330s by 100, so these should be all right. Next board up, I think, is the diff amp. Well, the differential amplifier went surprisingly quick. So next up, actually, we're going to do a preliminary power on test. I just want to make sure after all this work, we don't have any burn down or the unit still functions. And then we'll continue on to the next card. Doing a unit like this, you definitely want to step it in stages. You don't want to just shotgun the whole thing because you could introduce an error. Cap could end up getting in backwards. Things like that could happen. And what will end up happening is now you have a troubleshooting nightmare because you touched every board in the unit and you don't know if it still works or not. Or you don't know where the fault could be. So as long as we test it and validate it, I got 2 more cards done. If it blows up now, it has to be these 2 cards unless something else catastrophically burns down. But so we'll do a quick power up and then continue on. Everything seems to be working, and the meter is even reading more accurately as I continue going through the process and getting these things kicked over. 10 milliamp, 9999, and jittering around. We're about off by about 600 microamps, so for not being in alignment, we're even better than we were before. It's just continuing to improve, so gotta let the caps bleed off again because we had it powered up before I can go back in and put my fingers where they shouldn't be near the high voltage. Okay, we have the calibrator pushing 10 volts into the meter, and we have a good 10 volts. I did get the 3 bulk caps replaced. These were 125 by 450. I put some 180s in their place, and if we do some testing, 162 on a 125, so ESR is starting to go a little high, but 162 means we're going to see DC leakage, and so they did need to come out and get replaced. So we're up to burn-in testing on this unit. We're going to let this cook for a while and go from there. I was going to use snap caps and go in and bridge the ground leads because it did need all 4 ground leads. However, the caps wouldn't have fit physically, so I used adapter boards and got them all squared away. I put copper standoffs on the boards, and that also solved a clearance problem that I had with the bottom panel because those caps are in series. They're probably in the 1200 volt circuit. That would be why there are 450s, 3 of them in series. And I didn't want my wire insulation only goes to about 600 volts. So it would have been pushing the wire insulation and clearance to the bottom panel, which was grounded in the analog section. So using the adapter boards solved that problem quite nicely, and I don't have a clearance problem anymore. At this point, this unit is pretty much good to go. This burn-in testing goes well. It is now ready for an alignment. I said if this burn-in testing goes well, this unit will be ready for an alignment and then put into service. Its stability is a little bit better than the DC standard that I have been using. The previous DC standard was a 343. This is a 3330. This gives me current, but it also is more stable than the 3430. And currently for DC would be the king of the lab in terms of stability. I have some other stuff that's in the repair process, but it's not repaired yet, so it's not ready. The 343 does 20 ppm, rough DC accuracy. This does 6 ppm. So much, much more stable. And so very happy to have this, that I can put it into service, working on multimeters and other such equipment. For those that like that sort of thing, Nishikon GR series 105 degree C, 180 microfarad by 450 volts. 3 of these is what went into circuit. Well, I'm not unhappy with that. There's the 10 volt range, and to do a full alignment and calibration on a 3330B, one is I don't have a meter that has enough digits. It really needs an 8.5 digit meter to finish that up. The other thing is you need an extender card section. So some of the test points and measurement points and things like that you can't even get to without having the cards out. And the warm-up time on the 3330B is 24 hours at 100 volts. So you set it to 100 volts, you let it cook for 24 hours before you can even do the final adjustment and alignment. So it's really got to heat saturate, and it's very, very finicky getting this alignment to work. So I am very happy with this. We'll check the 100 volt range. And then we will also check the 1000 volt range. If I set the front panel up correctly. So I am not unhappy with that at all. Plenty of digits for 3.5 to 4.5 digit meters, and I'm probably not going to do anything. 5 would probably be the top end that my lab needs to service. 6.5, 7.5, and 8.5, they're going out. This meter, I do not calibrate this meter in the lab. I don't have its standards near stable enough that run 24/7 and all that good stuff. So this meter does get sent out for calibration, and then it just checks the 6500, which is my day-to-day meter. And then alignments and things like that, we do more on 3.5 and 4.5 digit meters and getting them up and running. So everything looks great, and this unit has passed burn-in tests, and this one's done. Thanks for stopping by the lab and taking a look at this 3330B, older calibrator, but still very capable today and very stable. So this will be a nice addition to the lab. If you like what you see, hit all the YouTube buttons, like, share, and subscribe. And if you want some additional content, check out the Patreon page. Patreons help keep the lights on here in the lab, and videos coming up to YouTube, and their help, as always, is greatly appreciated in assisting with the content. So, as always, in between videos, I'll see everybody in the comments. Bye for now, and I'll see you guys in the next one.